So now we're going to look at variables in C. And so variables are really, as I was mentioning earlier, some sort of human readable identifier that we give to a region of data, of memory. The data type or the keyword, the data type keyword we place in front of the variable lets us know how much space or how many bytes in memory are actually related to this variable, this keyword, this identifier that identifies our variable, right? So the variable type, which is what we explained before in these keywords with the data types, really only says three things, and that is the size in bytes, and so we can get this by using the size of operator, which we saw in the last tutorial video. The range of possible values, so this is whether it's an unsigned integer and a signed integer, whether it places the zero value in the middle of its range or at the beginning of its range, determines sort of like the upper and lower bounds that this number can show. Can it show negative values, or does it just show positive values with a larger range, right? Also, what's very important is that it also tells us about the operations that can be performed on it. So arithmetic, you can add 1 to an integer, you can subtract, you can multiply it, you can compare it to other integers, but you can't compare, generally speaking, an integer to a pointer. And we'll get into this when you know what pointers are, but the data type very much specifies the operations that can be performed on it in a standard sense, right? So there are, for instance, also the two type modifiers, which tell us also a bit more information about sort of various properties of the variable. And so we saw, I mentioned before, talking about this constant string and how it'll end up in read-only memory. We also can use the const type modifier keyword. And so what const does is it's telling the compiler this variable, like let's say I have a float called pi and I put 3.14 blah blah blah, this variable's value never changes. So I can put const in it and the compiler knows, hey, for the entire execution of this program, this variable's value will never change. So this allows for a few sort of advantages. It can make sure that we don't accidentally change it because it's read only. So we can't, let's say we're doing some physics application, we can't change the value of pi by accident in the middle of our application. That would be, fundamentally stupid. It allows us to optimize things. So it can move values from RAM, from which is quite limited and small, to like read-only memory. Maybe we'll just keep it on our flash. We'll never have to actually load it into RAM. Maybe, whether this is good for performance or not, it's another question. But we have the knowledge that we're never going to need to write to this variable, and therefore the compiler can make optimizations accordingly. And so this is also tied in with the third point, this constantly read-only memory. So this is very important when it comes to embedded systems, because embedded systems are very resource constrained, and so sometimes making things read-only to change where they're placed on which data segment of the board they're placed on can make a huge impact. Volatile is a keyword that's not used too much in sort of, like, let's say, basic or day-to-day programming of C. It has really two big functions, and that is that it sort of stops optimizations being done to a variable. So one common optimization that it really sort of can annoy people during debugging is that if you have a system where you can't actually debug and go in and click on the variables, and you have some, like with GDB, and you're using just print statements to read the value, if you don't tell the compiler that this variable is volatile, it might optimize it out if you never read from it. Like if you write to it but never read it again, it makes sense, right? Like this variable is never needed for anything. We write to it, but cool, if you never read from it, it may as well not exist. So therefore, the compiler just ignores it. It just gets rid of it. And so then when you want to go and print it to debug it, although by printing it you would in turn read from it, so bad example, but the volatile keyword tells the debugger to keep it in there and to not change any sort of like optimizations to sort of shift around the operation order and whatnot, because sometimes the sequence in which certain things need to happen is very important. And so this is sort of more linked to the first point, which is a very advanced topic of using where sort of like the operations or the contents of memory affects hardware, peripherals, and other sorts of systems. And so we need to be sure that things get done and in the right order. And so if we put the volatile keyword on front of a variable, it just says, hey, this might not make sense to you, Mr. Compiler Optimizer. Just leave it. I know what I'm doing. And so that's why it's really helpful, right?